Thanks, Arthur. And yeah, welcome back, everybody. Thanks for staying the course. It's good to see you here. You've got some really good talks, so it's well worth having stayed for. A whole range of mining, mineral processing, waste, circular economy talks. We've got a lot to get through. We've got 7 presenters, 5 of whom you see in front of you and 2 online. So we'll try and keep it as efficient as possible. And if at the end we've got some time for questions, that would be great. So quickly, I'll hand over to Chris Bray, my colleague from SRK, who's going to talk about strategic mine planning. So I'll become Chris.
Okay, these lights are very bright. But good afternoon all, and thanks very much for keeping the energy up. And for the last session, I was surprised that there were seven presentations, so it's quite a long session. We'll try and get through. So with the theme being around new technologies and so on, the presentation I have here today is really focused on strategic mine planning and to sort of adapt it to new technologies and so on. I just want to describe some of the strategic planning approaches that we would use within the SRK team in the UK that we're continuing to improve over time, and how we incorporate assessing new technologies as part of that process for clients. So strategic planning can be undertaken at any level, any stage of the mine development, and the level of detail and accuracy will vary considerably. Typically, we don't have all of the information that we would like to have, so we work with what we have to assess the project potential and value, define a basis for future studies, inform the continuing exploration strategy and investment decisions for the clients. Mining projects are becoming more challenging on many levels. The sort of geometries of mineral resources that we have to work with. I think a few of my colleagues there are smiling, thinking of some of the challenges we've had with those, the depth challenges, the costs involved, are bringing more challenges to the mine planning process, and makes it even more important to undertake strategic planning to find a path forward for clients. Strategic planning assessment is required to provide clear comparisons to inform the decision-making process and make it easier to make those decisions. The project setting, as many mine planning engineers find throughout their careers, influences significantly the options that are available for access for mining, logistics, and areas suitable for location of surface infrastructure and storage of mine waste and tailings. Other mine permitting and regulations need to be considered and seem to be increasing over time, that we need to include this in the mine planning process and strategic planning assessment. And other commitments include company commitments to net zero carbon targets, and we need to sort of encompass all of these constraints and project setting options within the options that we're considering. When we undertake strategic mine planning, we aim to focus on the goals, such as providing an independent, objective and balanced assessment of the options, really trying to provide a like-for-like comparison to put in front of the client, so it makes it easy to visualise how they compare against each other and enable the client to make a decision. With all of the options, we need to incorporate new equipment and developing technologies as it makes sense, and incorporate all that to really determine whether those new technologies can be incorporated or whether it's an opportunity for the future for the client. We also want to be able to understand the challenges, some of the limitations on the accuracy of the data that we've got to work with, any additional sort of challenges that need to be understood for future permitting requirements, such as carbon intensity, decarbonisation challenges, which are going to vary with depth, and ore grades, which are going to drive key energy, logistics and process and fugitive emissions from each of the options considered. We also want to be aware and avoid the roadblocks along the way. I'm sure some of the clients and consultants have encountered senior management who tend to get attached to ideas, technologies and locations before a proper assessment has been undertaken. Preconceived outcomes such as production rates. How many sort of clients have sort of given the impression that a higher production rate will be the best option for the project going forward? And we want to put all these together to really understand if that's a really important part of the best strategy option for the mine going forward, and avoid it if possible. We also want to manage expectations of our clients through strategic planning by being able to walk before you can run. And as part of that, we want to split strategic planning into two sort of phases there. The first one being high-level strategic planning. And this is just to establish the basic framework for the base case options to be considered going forward. As part of strategic planning, having undertaken many exercises with colleagues, it's all about narrowing down the options from, not trying to boil the ocean, limiting the options to really try and focus in on the best path for the client going forward. And part of that is establishing which mining methods make sense, what are the range of cut-off grades or values and production rates that we want to understand, what are the implications for mine waste and tailing storage on surface and underground between the options being compared. These days we're starting to look at the scale of emissions and including carbon at an early stage to sort of provide a direction for the environmental studies that are progressing even at the early stages of a project. But at the same time, high-level strategic planning, we're using a lot of assumptions, a lot of factors. We don't have detailed design, schedule tools available for us. We don't have geotechnical and hydrogeological modelling to inform the process. It's just to provide the early fundamentals for the base case strategy to go forward. The typical approach, the starting approach that we would normally take with our mining team in the UK is we want to provide a way of identifying all of the options that we want to assess. So we want to capture that right from the beginning before actually starting the strategic planning process. In order to do this, there's got to be a naming convention to be able to there's going to be so many options that come out of all the different matrix of variations that we'll look at, different variations of combined open pit and underground mining, underground only, different underground mining methods, different backfill methods. We can add whatever options we like there, but we want to try and capture that right from the start so that we can progress the whole analysis through right to the end. And we've captured everything that we wanted to capture at that stage, and we can learn from the results coming out at the other end. At the high-level strategic assessment stage, usually we have a resource model to work with. The minimum sort of starting point, the basis is the resource model. We're applying some basic stope optimizer, pit optimizations to it, and we work all those numbers through to the results where we're looking at the sort of physical mine waste, the ore produced, the final products, and of course the revenues at a high level. The typical sort of outputs that we get from this, you could see when we set up the options, we had a naming convention which we've carried through all the way through to the results. In this sort of automated approach of comparing the trade-off options, we're able to compare in a way that we can interpret the results based on the option being considered, the production rates, different production rates by table, and the range of cut-off grades that we're looking at. In this particular slide, we're able to see the range of MPVs, the sort of mineral inventories that we've got to work with for each of the options, as well as the sort of resulting grades that come from those optimization shapes used as a basis there. And if we just use a simple sort of color conditioning to those cells, it's very easy to see the trends between, you know, the range of production rates, the range of cutoff grades for all those metrics, and it makes it very easy to understand, you know, the positives and negatives when comparing the different options. This is results from another type analysis. We've moved away from a cutoff grade to looking at NSR values, which typically make more sense for multi-metal type deposits. Again, this slide is just showing the output physicals, comparing the mine waste and tailings comparison between the range of options that we're looking at. And it helps inform the strategic process to really understand, you know, does it make sense to send more of the tailings underground? How much waste are we going to be left with on the surface? And this can really drive the decision around, let's say, you can have, maybe the most economic option might be to have a super large open pit, but you might be left with 100 million tonnes of waste that has to be stored on the surface. And in some cases, that's just not going to be an option, even though it's the best economic case. So using this high-level sort of starting approach for the assessment, we can make some of those key decisions and sort of work towards more advanced strategic planning. Now, when we get to the more advanced strategic planning stage, we've got a lot of investigation has taken place. We've got a lot more data. We've got process test work. We've got advanced resource models, usually at higher confidence levels of classification. We've got hydrogeological models, geotechnical models, and we've already established the sort of basic base case parameters on, you know, slimming down those options, the range of cutoffs, the production rates that we want to target, and we can go into more detail there. And using a similar approach, we can start digging into those finer detail aspects of a project that will define the more advanced strategy for the company going forward. Things such as energy efficiency. More and more we're getting into comparing diesel versus battery electric type equipment. There's some examples there where we can start bringing in simulation and putting those results in, where we're getting a lot more level of detail and accuracy. And by the time we get to this stage, to start comparing options, there's so much detailed work behind each option. This is really why we need to focus and limit options early on. So we're looking at a much more narrower sort of range of options, which we're comparing and making those sort of more detailed choices there, which are going to produce a strategic plan that's going to be more defendable. When it you know, typically comes in at the permitting stage, it has to be defended against regulators and so on, that all of these things have been considered. So just to wrap up, hopefully we're going all right for time there, Richard. 6 more to go. Strategic planning can be undertaken at any stage of mine development or production, and the level of detail and accuracy is going to vary significantly. It can be early stage exploration, it can be an operating mine, an expanding mine, or we you know, a lot of the time we're restarting historic operations. It could even be applied to some of those early examples of mining historic tailings. You can apply this approach to pretty much any mining scenario, and you can take pretty much any range of options into the options to be assessed for the strategic mine plan. We're really able to nail down in a sort of like-for-like comparison all of the options that we're considering, and really help provide a direction for the project, whatever that may be: production rate, access, social environmental impacts, carbon intensity in energy consumptions. And the big one that comes up a lot of the time is management of mine waste, tailings and water. Phased approach can greatly assist in reducing the options, and strategic planning assessments are required for providing clear comparisons to inform the decision-making process and identify the preferred path for the future success of the project, which by that stage is practical and shown to be economic and backed up by detailed work. So that's pretty much a summary of a sort of how we would sort of navigate through the path of developing a strategic plan. So I hope that makes sense to you, and yeah, look forward to talking through more later. Thank you.
Thanks very much, Chris. That was very efficient. So, yes, and Yurko Martinez will now kind of continue the theme on underground mining with some approaches that he's experienced in his career. Yurko's a senior underground mining engineer at SLK with us in Cardiff. So take it away, Yurko.
All right. Good afternoon, everyone, and thank you, Richard, for the introduction. Well, as Richard said, I'm a mining engineer. I worked mostly in underground mines, and in my experience, the underground workflow is not totally understood sometimes, leading to less valuable outcomes. So the purpose of this presentation is to provide you with an overview of the underground workflow, the key steps, and the important consideration to look at, so you are better prepared when you are leading these kind of studies. Well, the mining projects are not getting any easier. I reckon that some of my colleagues has previously touched on those points. They are getting deeper, harder, with lower grades. And having a clear understanding of all the stages and all the key steps and the important consideration is critical to unlock the value of the project. And this is not only applicable to the mining studies in particular, it's for the mining projects in general. So this is applicable for the geology stage, for hydrogeology, geotechnical assessment, and all the ones that you can see there in that bullet point list. So regarding the mining studies in particular, that is the focus of this presentation. Some of the investigations will be undertaken early strategic planning stage that Chris presented very well in the previous talk. And that will define the mining method, the cut-off value, and the production rate. And with that information, you will be able to advance in the following technical stages. And for the purpose of this presentation, we will focus in the optimization, mine design, and mine scheduling. But if you want to discuss further any of the other ones in that bullet point list, please feel free to reach to us. So the underground workflow. Usually this is more complicated than we think it is. It involves interrelated steps and an iterative process. And I really like this image. I took this one from another presentation. It's not mine. So as you can see the reference at the bottom of the slide. But I really like this one because it clearly illustrates the iterative nature of the process. You first need to define your cut-off value, your mining method, and your production rate. So you can see there the squares with that input information. You will also need to define some geotechnical inputs and other inputs to continue with the blue squares there that are the focus of this presentation. So you have design, you have optimization, you will need to define a mine sequence and also a schedule. And that will enable you to define a cost model and a financial model that at the end will inform back your initial assessments. And you will need to probably iterate in the process to have your final outcome. So let's start with the first part of the process. This is the optimization. I reckon that there are more mining methods that only stopes. But time-wise, we will focus on the stope optimization that is applicable for long-hole open stoping or stoping underground method. This is basically a process of defining mineable shapes. That means geometrical conditions and economic conditions. So since you have already defined your cut-off value, you can move forward into this optimization stage. And there are some important considerations that you don't need to overlook. The first one is the block model. That is the interfacing between the geology team and the mining team. And you need to ensure that you are not compromising any information in the handover process. So it's a good practice, for example, here for the mining department to run all the statistics again, to have tonnage, grade, and metal, and cross-check that you're obtaining the same results in your mining software that the geologists are obtaining in their geology software. Sometimes it's not the case, and you will need to dig in detail to see what is happening. So it's a good practice to avoid compromising any information in the process. Then you will have another consideration about the cutoff value. That could be either marginal or break-even. Dilution as one of the important modifying factors. You can use a dilution scheme approach or a percentage. The mineralization reference provided by the geos. You need to ensure that you have valid solids or modified solids, and that will guide your shapes orientation. The minimum mining width, that is dependent on the mining method. Pillars, depending on your mining method selected in the previous investigations, you may have reed pillars or silt pillars or regional pillars to ensure stability. And the sub-level spacing, that will be an outcome of the ore body complexity. So if you have a very complex narrow vein, you will try to keep that very closely spaced. But if you have a continuous vein, you can go for higher level spacing in order to minimize development costs. And last in that bullet point list, the resource classification. So if you're running this one for resources or for reserves, you will need to treat classification differently. I added here an additional slide regarding the particularly dilution, because sometimes it's a point that causes some confusions. And that is probably given that there is not a unique definition for dilution. So some companies will calculate that differently. And as an example, Western countries tend to calculate the dilution as a percentage of the in-situ mineralization, while Eastern countries tend to calculate that as a percentage of the total run-of-mine material. You can also apply not only a percentage approach, you can apply a dilution scheme approach, as in the image there in the, on the right. And you will model there a hanging wall and a full walled wireframe scheme, and that will enable you to calculate the grade directly from the resource model and to get a more accurate result. And if you are an operating mine, you will be able to calculate your reconciliation numbers. That will improve your knowledge of your ore body and your operation efficiency. So once you have run this optimization, it's very important, and sometimes this is not the case, to review your results according to your wireframes and according to your block model. So in this case, we have run the stope optimization. We obtained the green shapes there. Those are the stope resulting from the optimization process, but they were not covering completely the vein. So what we did here was to cut the vein in little pieces. The vein is that one colored in blue and red. And the ones in blue are below the cutoff rate, and the ones in orange and red are above the cutoff rate. So this is making sense. Most of the little shapes are below the cutoff rate, but there are some places there where you have a very good grade and is not captured by the optimization process. So if you dig deeper into this one, you can do a cross-section as the image on the right here. And we realized that that is a very narrow zone, narrower than the minimum mining width defined for this particular mining method. That means that if you want to put on a stop there, you will have extra dilution, and the grade is going to drop below the cutoff rate. So that is a cross-check to be sure that you are getting the result that makes sense, and it's important to not overlook this one. So after you have completed now your early stage assessment, then your optimization process, you need to define your inventory. Defining the inventory means to select the stopes that are going to make it to the scheduling. And for that, you will need to run some economic checks. This is especially important for the stopes that are isolated. Usually, those stopes are going to be above the cutoff rate, just because you run the stop optimization like that. But sometimes they are very far away from the rest of the stopes, and the development costs is not reflecting the assumptions made in the economic assessment. And therefore, you will need to calculate the number of meters to reach those stopes and calculate the revenue obtained for those ones, remove the ones that are not making any economic sense. Also, you need to remove the marginal stopes. Again, some companies define marginal differently, but for the purpose of this presentation, the marginal stopes are the ones that are not paying for development. And in this example here, in this image, are the yellow ones. So in this case, you can see that there is one there that says included in the schedule. That means that that stop is a marginal stop that don't require to pay for the development, because the break-even stops that are the purple ones are paying for the development. On the other hand, the one that is in the image on the left is not going to be included in the schedule, because if you want to reach there, you need to execute a couple of tunnels, and that is not paying for that. Some consideration regarding the mine designs. Well, this is not an extensive list, but are one of the most important ones are the decline. You can have a straight decline and, of course, a screw decline. Both of them has pros and cons. You will need to define your portal location. Is it a good practice to try to orientate the color of the portal at the right angle with the major joints, stability-wise? The development dimensions, that is going to be well, that need to fit for purpose for your equipment fleet and your services. The equipment operability, turning radius, maybe you need to strip the corners of some accesses or strip the back for some loading points. Are you going to have diesel or electric fleet? If you have a diesel fleet, you most probably will require additional airflow requirements. If you have an electric one, you will need to include some caddies here and there for battery swapping. So the design will be influenced for your previous decision. Material handling strategy, you can have conveyors or passes, loading points, rehandling, some stockpile for backfill, pillars, what is your stand-off distance to your out body, or the distance in between the tunnels. Your underground infrastructure, you may have workshops inside the underground mine, or you can have a processing plant if you don't want to have a big impact at surface. And your production rate also is going to influence your design, because you may want to have different independent areas to increase your annual production rate. So we have completed now, well, theoretically completed now, the strategic planning, optimization, inventory, and design. And the last part of this presentation is the scheduling part. So scheduling is basically defining the who and the when. So who is going to execute each one of the tasks in this mine plan, and the when is the date. So basically this is reflected in a mineshed Gantt chart as the one on the right. And for doing that, you will need to have a clear understanding of all the activities involved in your process, the rates, the resources, and the mine sequence. This is an example of different mining sequences. Well, you need to define first the dependencies, and the varieties dependencies are basically the hard constraints in between the activities. And priorities is the preferred order. So if you have a resource that is able to go to two different locations, what is a priority? You can see here an example on the left with a particular bottom-up sequence in a primary, secondary sequence as well. That means, in simple terms, that you will need to mine first the level below before going to the level above, and you are going to mine first the blue ones within the level before mining the brown ones. And that is well illustrated there with those little arrows. Another example is the one to the left. That is the maximum unsupported span. So that is, for example, a longitudinal stops. You can have, in this case, based on the geotechnical assessment, more than 50 meters. So you need to ensure that in your sequence you are not scheduling production activities that are extending that distance. Some considerations regarding the mining schedule are the one in that list. So the first one is different scheduling contexts. It's not the same having a single phase context that a multiple phase one. Usually, if you have a single phase, you will try to maximize utilization of the phase, as opposed to the multiple phase context, when you try to maximize the utilization of the machines. In that case, you will need to define different production rates for the jambos and for development. The productivity model, that can be taken for benchmark data for other similar projects in the region or in the same mining method. Or you can develop that by first principles. That means calculating all the little in-between steps of the tasks that you are modeling. And so typical activities to be modeled in a mine schedule exercise are the development ones, so lateral development, vertical development, and the production ones. So production drilling, bogging, haulage, backfilling, occur in time if you have cemented rockfill or pastefill. And finally, to complete this activity, or this step, you will need to define some scheduling goals, typically ramping up to a steady production rate and avoid any peak in any kind of tasks, because that results in having requirements of additional machines for a short period of time, and you don't want to increase your capex. So, in conclusion, mining projects, and particularly the underground projects, are usually more complex than what we think they are. They require an early stage strategic planning assessment, as the one that Chris presented, and they require a clear understanding of the process in order to unlock the value of the project. So hopefully you have now a better understanding of the process, but if you want to discuss in more detail, please feel free to reach to us after these presentations. Thank you.
I think that was bang on 15 minutes, Yoko. Well done. Thank you very much. So now you have to follow that, Umut. So I'd like to introduce Umutcan Gelisen from Dharma Engineering. He's going to give us an overview of the EPCM process and the various steps involved in that. So please go ahead.
Thanks for introduction. Good afternoon, all, and thanks for attending this session. My name is Umutcan Gelisen, and I'm mining engineer working as a project supervisor at Dharma Engineering. Today, I would like to talk about major critical steps for mining projects to make them successful. As a case study, I will summarize project development phases of a real gold mine project, from exploration to operation. These are the resource estimation, scoping study, bankable feasibility study, and EPCM. Before that, I will introduce our company briefly. We are an engineering company located in Turkey and have been serving in the mining industry since 2005. Our mission is to create a highest and competitive value for our clients for their projects. We provide services from exploration to resource estimation, mine planning to processing plant design and supply. Besides, Dharma has submitted feasibility studies for many projects so far, which comply to the reporting codes such as JORC and National Instrument. We have been collaborating with Caps Cassidy for more than 12 years. With more than 50 years of experience, KCA is one of the best-known engineering company in heap leaching and cyanide technologies, as well as any other metallurgical services they provide. KCA and Dharma has completed several gold mine projects in Turkey. In these projects completed between 2013 and 2019, Dharma and KCA undertook different scopes, such as metallurgical test works, feasibility studies, and of course processing plant design and supply. As you see, the processing method is different in all projects shown as Mercro, CIP, heap leach, and CIC. Provided services are specific to the project and actually an output of the systematic steps that will be explained in this presentation. This case study is rare as an engineering company involved in almost all critical project development phases and analyze the impact of all these phases on each other. These steps are important to develop project at optimum cost with timely and right decision processes. Also very effective to secure finance when needed. Before continue, I would like to give a brief information about the project owner. TÜMAD is one of the most important gold producers of the Turkey. Apart from Lapseki and Evrindi project in operation, TÜMAD continue to exploration and developing new projects. Evrindi and Lapseki gold mine projects were awarded in the best project finance deal in 2017 with an $2,050 million credit supplied from EBRD. Also, TÜMAT is the first Turkish mining company, has the International Cyanide Management Code for their operation. And thanks for them trusting us almost from day one for their great projects. For the project you see on the screen, Dama involved as an exploration consultant, then took responsibilities such as resource estimation, bankable feasibility, and supply for the ADR processing plant with KCA, which you see. Irini Gold Mine project successfully completed in 2019. The mine has 100,000 ounces of gold production capacity per year. Major project development phases are the resource estimation, then the scoping study, which guides the client decision to continue, and then the bankable feasibility study, compliant to national instrument for securing finance. And finally, EPCM to start production. The output of all these works is different and critical for projects come to life by increasing the sensitivity of the data and experimental value. At the beginning, all available exploration data is investigated and verified by using proper methods. And this data was used to generate project's geological model. Another important output of this phase is to create block model, which is base for the mine design and other future technical studies. The next step is scoping study. We can say that the scoping study is the base of the feasibility study as it has the almost same content. The main difference is the amount of available data and accordingly sensitivity of contingency levels. Scoping studies are very important and very effective in the client's decision for the next step. Scoping studies also produce key important outputs, such as mine plans, processing methods, and some trade-offs to estimate the CAPEX and OPEX to decide for the next phase. For example, we have created an optimized crushing layout by considering many parameters such as existing topography, stockpile sizes and positions. Also, laboratory test works show that the gold has higher recovery in favor of HPGR crushing than the conventional crushing circuit. These outputs are shaping the next step. Bankable feasibility study. Many projects are stopped due to lack of funding. Bankable feasibility studies are very important in this respect. In these reports, the overall sensitivity is as low as 10 to 15% and provides great confidence for investment decision and financing the project. Final mine planning and scheduling is one of the important outputs of these studies, as well as final economical assessments. In the example shown at the bottom right, outputs became more detailed from beginning to this phase. Okay, after bankable feasibility, we as Dama and KCA were awarded to design and supply ADR processing plant for the project. In this phase, engineering, procurement, and construction activities were carried out in parallel to minimize delivery time of the plant. Turnkey project management capabilities are important for successful implementation of the mining projects, besides geology, mining, and mineral processing. After several years of project development, the first gold poured in June 2019, and this ADR plant is one of the biggest in the region. In the light of our experience, ore body defining, project development alternatives and risks, test works and design and project management is the key for mining projects to be successful. And in this presentation, I showed in which phases all these important steps were completed for even the project. Making mining projects efficient and providing best value requires a right roadmap. Best engineering practices minimize the economical, technical, and environmental risks of the project. For this case study, bankable feasibility had significant impact on financing the project, and estimated costs were well inside the range of real investment. And the plant achieved the target production with safe operation under the International Cyanide Management Code requirements. Thank you for your time, and thank MINEX team for this great organization.
Thank you. That's very entertaining, very interesting, yes. We may have some time. Everyone's being so efficient, we might have some time for some questions later. So you were probably not quite ready, Glenn, but you'll have to jump to the fore now. So I'd like to introduce Glenn Burridge, who's the Executive Director of the European Federation of Geologists, and he's going to talk about robotic miners in the mining industry.
Right. Good evening. Probably you'll need a coffee by now, don't you, with all these speakers? So thanks again for the invite. And perhaps before I dive into robotic miners, just an introduction to what the European Federation of Geologists is. It's this federation of the professional geology associations of Europe. There's bubbling around 27, 28 members at the moment. And we're all about trying to be the voice of professional geology in Europe. And we do that through many means. And one of them is through projects which are funded. In this case, this is through the European Union's Horizon 2020 program. We have about 7 or 8 of those on the go at this same time. We often get involved in to some extent, the technical aspects of it, but often the dissemination and outreach around them. That's what I want to talk to you about today in terms of this topic here. And I'm going to start, a lot of it's going to be about the challenges, but at the end I want to be able to provide a vision, which is what this project is aiming to do. And next slide, please. Sorry, I need the clicker, don't I? Now, what's the inspiration for all this? Burrowing animals is where these guys started, and it's a large consortium. At the end, you'll see the number of people involved from all over Europe, and they're particularly obsessed with the creature on the top left there, the mole cricket. But a number of creatures work in this way in terms of their own sort of very shallow mining, centipedes, termites, and there's plenty of examples of this from ichnofossils in the geological record. And the way they tend to do things is that they create these sort of fractal trees, which was intriguing for the question of mining with human-driven mining. Now, this is the dream in a way, is to be able to put these little robots down into the places where we want to excavate. And the idea of it, they could be sent via a borehole in modules, and then when they get down to the mine face, or they would be down there, that's probably being the first contact with the subsurface, that they would self-assemble. They would become a fully functioning robot at that stage. They would have the ability to sense their environment, to detect ore, and then, I mean, this is not just exploration we're talking about here. This is production. Actually, I noticed at the back there we've got 2 posters. MINEX Up is a derivative of a previous project supported by Eurasian 2020 called MINEX Min, which some of you might have seen a presentation on. I mean, that's very much exploration. That's a beach ball-sized autonomous robot that floats around in a water aqueous environment and is exploring particularly abandoned mines. Robo-miners here is really more in the production sphere. Hence, they're going to be producing slurry. And pushing it even further, can they be reconfigured on the fly as they adapt to their environment? So this is the dream anyway. And here's some of this, the spec that they wanted. And we perhaps shouldn't get too focused on the image here of them being legged robots. This was one of the ideas that they started off looking at. But there's several alternatives, and it kind of demonstrates the concept at least. And we want something, as I said, that can excavate. So it needs to be able to sense where it is and what it is situated in. And this is the bit that surprised me when I first found out about this. Perhaps in those images there, you have this idea that these would be quite small. The size range, and here's the kind of ecosystem of family tree of robots. The ambition here is for something that's a ton or more in terms of its size, which raises all sorts of questions, of course, immediately about access. If this is a modular thing, that's quite a big piece of kit, and the power requirements, which is something that's come up continually in this project. So, problem number one is GPS is presumably not going to work underground. So the first thought is, well, we need some kind of inertial navigation system, which is kind of how aviation navigation started out before GPS. So it takes an initial fix and then navigates relative to some sort of 3D model of the world and the space around the device. So will the geological models will be able to be sufficient? Can we update that possibly into some kind of 4D time-lapse version? Can we transmit enough two-way communication with these creatures to be able to enable all of this? And again, how's it going to be powered? And then, there's the question of the control of these things. We need to think about, it's basically going to be semi-autonomous. So we want these devices to be able to operate with a certain amount of using these sensors that they have to be able to respond to the environment. But there's going to be some sort of pre-programming beforehand to enable them to work to some kind of strategy and in an efficient manner. The initial idea was, again, aspiration was to try and model what these creatures are doing, so be bio-inspired once again. Here, the famous mole cricket, which is an attractive idea and is something which they want to pursue, but we've got questions also around the hydraulics there and getting water, in this case, in and out to enable that. Modularity, this is seen as a key enabler, that once you've got the thing down there, you want it to be able to operate in changing conditions, for it to have a degree of resilience. And so, as you can see here, you may want to adapt the robot's configuration, its size, the amount of power required to deal with various geological scenarios. And that word resilience, so based on four pillars, the ability to continue going even with things that perhaps are broken, to be able to reconfigure itself physically, and also in terms of perhaps its software, to be able to adapt its behavior and as a consequence of that, the actual system itself, the way it's operating as a system. And this would give it the flexibility to continue working without having to be extracted, and to, as a product, to be more amenable to different locations. So this is the concept, I guess, as an overview here, with its sensors, it's able to digest as it's sensing its environment and produce, which raises questions, of course, where does that slurry go? We're going to need quite a few geophysical sensors on there for it to have that kind of meaningful intelligence as it's moving around, and to navigate to what might be quite restricted or body forms. And then there's the question of the mine design itself. Various scenarios there. Are you happy leaving these ore blobs there? Do you want this thing to be, how efficient do you want it to be in terms of the passage of the slurry at the back of these robots? And do they work as a clan, in a cluster? Certainly when it comes to the question of power, could you have basically a sort of mother robot which is then feeding off smaller ones, or are they all the same? So in terms of what the productivity they were aiming for, there's some figures at the top. And as part of this also, they were collecting together suitable mines from the various databases kicking around, and to examine which mines might be the most amenable to this approach. So the idea is that this could be a way to improve the way that we're going about mining. We're hearing this again and again this afternoon, and we'll summarize that at the end, what the benefits could be if we can design such robots. And I mean, we all know why we would like to robotize. This is the way we're doing things now. I mean, I come from the energy business. I'm just amazed at at the depths we have human beings in environments which in the energy business you'd be obviously going nowhere near, and you'd have very restricted boreholes. It's quite incredible. So the idea would be to reduce the size of the galleries, to do the dimension of the robots rather than human beings, and to remove the need for all the support systems that go with putting human beings and their supporting machines down at depth. And potentially to extend into areas, if you think about where robots are used today, into areas that human beings will never be able to go, or because of the ambient conditions and the harm to them. So the takeaways from all this, this idea of trying to minimize the footprint, robotizing could help mines have a smaller footprint. I don't know about becoming invisible, but certainly having less need for human beings, and they will work at greater depths. They will be more fit for purpose in terms of the mining design. The excavation of the rock, therefore, will be less, and there will be an optimization of the ore that comes to the surface. Do we see in 20, 30 years' time no personnel in the mine whatsoever? That's certainly the vision put forward here. The reduction of groundworks and access routes, dewatering is reduced, less waste overall, and cheaper capital cost. So advancing this vision does require a completely new view of what mining is all about. And that it will be built around what the robots can do. And as I say, the challenges involve really how do you have these robots operating down there? There's lots of great things we can do in terms of sensors, in terms of how they navigate. We are pretty good now at navigating. We see this, for instance, from oil and gas. Many kilometers in 3D and 4D, you might say. But the things that the guys working on this commonly are saying that it is a power problem. So, and then after that, how you get the slurry to surface, even if it is less than what you are dealing with at the moment. But if we can get it right, it opens up some fantastic new avenues. And here's the team working on this from across Europe. As often the case with these Horizon 2020, now Horizon Europe program projects, they involve a wealth of different expertise. So we've got robotic engineers, we've got geologists, there's often social scientists in there, and communication teams as well. So thank you for your time, and hopefully raises some interesting questions.
Thanks, Glenn. Maybe you can come back in 15 years and tell us what the difference is between the concept and the reality. No, that's really interesting. That'd be great. Well, we're moving on nice and swiftly, which is good. Next up, we have Fabrice Fayola, who's Vice President of ECOBA, which is the European Coal Combustion Association. He's going to talk to us about the circular economy, which I guess is another key theme of the sustainable mining that we've been talking about these last 2 days. So go ahead, Fabrice.
Hello, everyone. I'm Fabrice Fayola. I'm the VP of ECOBA. Let's speak about ECOBA. ECOBA is a European Coal Combustion Association. What does it mean? We don't speak about mine, but after coal mine, there is often power plant, and after coal has been burned, there is ash. And ECOBA is in charge of promotion of ash from fresh product, but from stockpiles too. ECOBA was established 32 years ago. We have 26 members in 17 countries in Europe. We are represented in the European Parliament to change rules and standards to promote ash for concrete, for cement, for hydraulic binders, from aggregate, from road construction, etc. Fly ash can be used in a lot of applications. We can see different type of coal used in Europe. In West Coal, it is and it was because it decreased a lot out coal, and in East we have out coal and lignite. The CCPs, the result is totally different. The quality is totally different. In Europe, combustible fuels represents an half of the electricity. Quarter from nuclear, and wind, solar, and is increasing, but not perhaps so fast than expected by the governments. The Parliament voted the package of Fit for 55. Fit of 55 is to decrease CO2 emission of 55% from now till 2030. And the target is to be net zero in 2050. What does it mean? It will reduce coal, will reduce ash use. And the quantity of ash is decreasing a lot. It means in a lot of countries we import ash from India, from Turkey, from different countries where there is ash available. The coal exit has been established. In a lot of countries, they stopped coal. In UK, it's not established, but they stopped coal for electricity. In France, it's stopped. And it means we need fly ash in West countries. And I think in East countries, there is a lot of stock which can be used in West countries. The quantity of CCPs is decreasing because the production is decreasing too. And what we need, ECOBA wants to develop its activity and to improve quality and availability of fly ash. What's in 3 steps? Firstly, in finished fresh production, and secondly, in cross-boarding, in import from India, from Turkey, from other countries, but shipping price is very expensive now, and perhaps for managing stocks and reuse from stock. In West Europe, a lot of project has been started to reuse all stocks in drying fly ash, in processing fly ash, in grinding, and to be used in cement and concrete factories. For example, in Gelcommon in UK, there is a stocked 46 million tons. It's all stocked, never used, and we start exploitation. In France, wet ash is used a long time ago, and we have a processing with dry fly ash. The European Green Deal wants to develop waste in using to new construction. What does it mean? We can use more and more waste, like fly ash, like GGBFS, like other product or byproduct to new constructions. To develop cross-boarding, the shipping price are expensive and the silo storage are expensive too. But we think it's the future of fly ash because cement and concrete factory are very interesting in fly ash. Why? Because due to the quality, they reduce water demand in using fly ash, and due to reducing CO2 tax. Because a lot of countries have a CO2 tax and cement factory has CO2 tax. In using waste, they can decrease these taxes. So the CCP production, depending on energy production, it decreased. Fly ash is decreased, but stocks are always available. I thank you very much.
Thanks, Fabrice. Yes, lots of food for thought there. It's interesting to think that we're running out of ash. So, now the next two presenters are online. Hopefully we haven't caught them out by being too early. So first up is, let's get my act together here, is Jason Tatman. He's the Overseas Marketing Manager at the Ganju HPY Technology. He's going to talk about sensor-based ore sorting. Are you there, Jason?
Yes, I'm here.
Oh, great. Good. Nice to meet you. Hopefully we're going to look at you later.
Sure.
Right, I think you're ready to, are you ready to go?
Yes, I think that we prepared a video before.
We've already, it's already pre-recorded, yeah. So I think the team are ready to press the button on the video, and then you can step in at the end if you want.
Hello, everybody. Welcome and thank you for attending today's presentation. First and foremost, I'd like to thank MINEX Europe for allowing us an opportunity to speak at this year's conference. My name is Jason Tatman. I'm an Overseas Marketing and Sales Manager at HPY Sorting Technology. Our company specializes in sensor-based ore sorting machines. We have spent time revolutionizing and will continue to revolutionize the mining industry. Before we dive deeper, it's important to understand what is ore sorting. Ore sorting is a process that allows companies to use sensor-based technologies to pre-concentrate or sort ores containing commercially valuable minerals and waste rock. Our machines are typically placed during the crushing stages, allowing for future steps such as grinding, ball milling, and flotation to yield better results and save on resources such as water and energy. Sensor-based ore sorting has been around since the 1970s. However, recently we've seen a huge leap in accuracy and efficiency due to technological and information revolutions. Our company has continued to add on to that huge leap. As the only company in the world to focus solely on ore sorting, we have put in our efforts to make sure that our innovation and technology continues to satisfy our customers' needs, as well as continue to advance ore sorting in the mining industry. Ore sorting has 3 basic steps. The first is to identify the ore. Second, the data is collected by the sensors and sent to the machine so that it can sort the ores between usable ore and waste rock. Our company focuses primarily on 2 types of sorting technologies. The first being intelligent imaging. The second is XRT X-ray technology. As you can see on the diagram below, the first picture refers to the intelligent imaging and looking at surface characteristics of the ore. Characteristics such as size, color, density, weight. However, as many of you know, it is difficult to detect commercially valuable minerals within ores by just looking at the surface. So we dive a little bit deeper. We use X-ray technology, and our AI algorithm is able to identify and determine commercially valuable minerals within the inside of the ore. Then we are able to sort between usable ore and waste rock. Our AI algorithm has been a big contributor to our success. Our AI algorithm was pioneered and created by our company to ensure that we have great results in terms of accuracy and speed. The Windshoe algorithm sees identification accuracy of up to 99.5%, a recovery rate of up to 98%, and a rejection rate of up to 90%. The combination of our AI algorithm and detection technologies has led us to bring many values to our customers, both economic and environmental. In terms of economic value, on average, our machines give companies economic benefits of 3.13 million USD per year. This is caused by increased sorting quality and reduced sorting costs. In addition, we have very low operation and maintenance costs. The costs come out to less than 1 USD per ton. In terms of environmental benefits, we see a reduction in energy consumption in the flotation and grinding processes due to the pre-concentration and sorting of waste rock and usable ore before it enters those processes. In addition, we also extend the service life and reduce the pressure of tailings ponds. While reducing the number of harmful chemicals seen in traditional ore sorting processes, we also see a reduction in water usage. Through the combination of economic and environmental values, we are able to create more cost-effective, productive, and greener mines and beneficiation processes. A little bit more about who we are. As mentioned, we are HPY sorting technology. We were founded in 2015 in Guangzhou, China, and since our inception, we have sold over 300 machines, giving us a 73% domestic market share and the market leader within China. Since 2015, we have won many honors and awards. 2 we are extremely proud of. The first being awarded Seed Unicorn Enterprise by Jiangxi Province in 2018. In addition to World's Advanced Ore Sorting Enterprise by the Chinese Non-Ferrous Metals Association. We've also taken steps to protect our innovation, technology, and competitive advantages by having over 100 different types of patents. You can see our customer map. We have worked with customers both within and outside the borders of China. Since 2015, we've worked with over 70 different customers. Some of our customers are the biggest mining companies in China, including Zijin Mining and Shandong Gold. We've also extended past the borders, working in Tajikistan and Russia. We look forward to continuing to grow, working with more companies, and being able to bring benefits globally. Here's a quick look at our product line. We have 4 products. 3 of them were introduced last year. The first is the Circle series. This machine we are extremely proud of, since it is the world's first ring-shaped structured ore sorting machine. Later, I'll dive deeper into why we chose this structure and what benefits it brings our customers. Next to it is the Golden Coal series. As the name suggests, it's specifically for coal. It sorts coal from 50 to 300 millimeters and sees a belt speed of 1 meter per second. On the bottom left is our Insight series. It is made for ores that are more difficult to detect with traditional ore sorting machines. Combining both VIS HD imaging and X-ray technology, we're able to fully examine the ores and determine which ones have commercially valuable minerals. The last one is the Classic series. The Classic series is the most used and most popular machine throughout China. Since 2015, we've continued to improve on this model, and our customers have seen great results because of it. First up is our Circle series. Our Circle series gives customers an average of 4.5 million USD per year in economic benefits. This is mainly achieved through reduced electricity costs, reduced water costs, reduced maintenance costs, reduced tailings disposal. This overall creates a reduced carbon footprint, which helps companies create a greener and better beneficiation process. This machine, compared to traditional machines on the market, has 2 times the sorting accuracy, 3 times the processing capacity, but it only takes up 1/5 of the surface area and 1/3 of the energy consumption. In addition, this machine utilizes aerial imaging and free-fall technology to allow for 30% higher identification accuracy. Here are a few models of our Circle series. However, we are able to tweak and adjust the machine in accordance to customer requests. This machine sees grain sizes from 5 to 90 millimeters while having production capacity that can reach 300 tons per hour. Here is a quick video on our Circle series. As you can see, when compared to a traditional ore sorting machine, the traditional ore sorting machine uses a belt. The processing capacity, as well as the row of air jets, is limited by the width of the belt. However, with the Circle series, we chose the ring shape, circle, because it allows the ores to fall at 360 degrees. This allows for an increased processing capacity of over 3 times. In addition, the air jets cover the 360 degrees, which is also a factor in the increased processing capacity. When looking at the video, you are also able to see the free fall. This free fall contributes to identification accuracy. With traditional XRT ore sorting machines, using the belt often leads to foreign objects or interference with the belt. The free fall allows for the ore to fall in space, allowing for the imaging and X-ray source to accurately identify the ore. Something that's not seen in this video is that the algorithm is also tweaked to adjust for the Circle series, allowing for higher identification accuracy as well as speed due to the higher processing capacity. Another note is when the ores are transported by the conveyor belt and drop into our vibrating feeder, they also come into contact with a vibrating disc. This disc ensures that the ores continue to evenly fall at 360 degrees to ensure that all benefits of the Circle series are able to be reached at all times. The next machine is our Insight series. Our Insight series is the most customizable machine. As mentioned before, this machine is made specifically for ores where the commercially valuable minerals are harder to detect, such as gold or molybdenum. Through the combination of using both VIS and X-ray technology as well as free fall, we are able to achieve great results with this machine. This machine utilizes a short belt. Because earlier we did mention that the belt width does influence the processing capacity, we have made this machine at 1600 and 3200 millimeters. After the ores have crossed this short belt, they enter free fall. Where similar to the Circle series, during free fall, aerial imaging is able to capture the ore in addition to X-ray technologies being able to determine what is within. That way we are able to accurately identify which ores have usable minerals and which ores are considered waste rock. This machine, compared to other machines on the market, has 1.5 times the sorting capacity, 1.4 times production volume, as well as only using 2/3 of the energy and 1/3 of the floor space. This is our Golden Coal series. Our Golden Coal series is made specifically for coal because oftentimes when coal is brought to the washing or processing plant, it comes in large grain sizes. That's why our machine is able to process sizes from 50 to 300 millimeters. However, the size doesn't affect the speed. We see an average belt speed of 1 meter per second. In addition, this machine brings a lot of environmental benefits. We see a 3/4 reduction in CO2 emission, a 2/3 reduction in wastewater, as well as a 2.4 million USD reduction in infrastructure investment. Altogether, this brings economic benefits of around 3.8 million USD per year. Last but not least is our Classic series. Our Classic series is the most widely used machine in China. This machine brings around 1.5 million USD in economic benefits. Our belt speed averages 3 meters per second, and the machine is only 16.4 meters squared. All of our machines are connected to our cloud platform. Our cloud platform allows for companies to have real-time monitoring. They're able to see error detection, they're able to access a Q&A manual, they're able to access online support with our company, parameter controls, as well as data monitoring. In terms of data monitoring, we allow companies to break down their data daily, weekly, and monthly. Therefore, they're able to analyze the production of the machine and ensure that it is continuing to operate at their expectations. All of our machinery is extremely safe. We've ensured that they are all under level 2 protection. If you think about each time that you go to the doctor, you receive about 10 millisieverts of exposure each time. Our machines only emit 0.5 millisieverts per year, which ensures the safety of all employees and workers that are working around or with the machine. Our first case study is a great example on how our technology is able to help in terms of waste rock. Shandong Xinghui reached out to us saying that waste rock piles often contained usable gold. We were able to use our Circle series to detect which of these waste rocks had usable gold, and were able to help them sort and reach a recovery rate of around 58.41%, which was exceeded their expectations. This helped create more economic benefit as they were able to bring more gold to the market and create more profit for the company. Another great case study showcasing our machinery helping with economic benefits is with Yunnan lead and silver oxide mine. Our machinery was able to help them see an increase in resource value of 1.5 billion USD per year. We've also worked with foreign companies that have mines within China. This specific case is with ICL Group from Israel. With ICL Group, we were able to increase their usable ore by 5 million tons, in addition to giving them a value creation of 29.5 million USD. One of the last examples showcases our Insight series. In this first video, you were able to see the inside of the Insight series. However, that's not too clear. Let's take a slower look. These are a lot of examples on how our company has continued to push and innovate to ensure that our technology continues to revolutionize the mining industry. We look forward to future opportunities and working together to create a brighter future. Thank you.
Thanks, Jason. That was great. Really entertaining. Very interesting. Very interesting. A lot of new ideas that probably many of us have not seen before. So, if you can hang on for another 10 minutes or so, when we do the last presentation, there might be some questions at the end. We've just got one more to go, and that's from Michael Rada, who's going to talk to us about the mining industry of the future in the age of 5.0. Are you there, Michael?
I am here.
Oh, hi. We can see you. Good. Well, please go ahead with your presentation.
Good morning, ladies and gentlemen. I would like to present you the next Industry 5.0 keynote. After 2 years, we will aim the mining industry again and the impact of Industry 5.0 on the mining industry. My name is Michael Rada. I'm human and I'm the founder of Industry 5.0. And before we start, let me ask you 2 questions. The first one is who we are, because we have many titles. We are managers, presidents, chairmen. We are students, producers, teachers, fathers and mothers. With every single title, we are forgetting one. We are human beings. Living ones, not like this man on County Art of Pilsen Brewery. And if we do realize who we are, let me ask you the second question. where do we live? Because we live in beautiful cities like Roubaix, Pilsen, Paris, Brussels. We live in beautiful cities which we fill with trash. We work in a factory which produces in one day more trash than a city in a month. We produce products which frequently, before reaching the end user, become trash as well, and we store them in big metal houses filled with air, asking for more to be built to store more trash inside. And at the end of our shift, we leave, go home next to the output of our production. And we arrive home and maybe we realize that something what was called food before is called bio-waste today. And we look at the red sky above our head asking us, where do I live? This question will be answered today. But before we do that, let's speak about the mining industry, which I asked Wikipedia about, and I have one more source. I asked my own father, who spent all his life working in a mine. Mining is the extraction of valuable materials or other geological materials on the earth, usually from an ore body, lode, vein, seam, reef, or placer deposit. Deposits form a mineralized package that is of economic interest of the miner. In the last decades, new mines has been identified in mining of data, information, know-how, intellectual property, and with Industry 5.0 came one more, on-the-ground mines, which we will speak about later. Industry 5.0 is the first industrial evolution ever led by man, by human. It's based on the principles of systematic waste prevention, industrial upcycling, and it was launched on December 1st, 2015. Industry 5.0 recognizes and prevents 4 types of waste: physical, social, urban, and process waste. And their principles has been already implemented since 2013. And in 5 years, it prevented more than 1 million metric tons of products and materials to become waste. What is the existing reality? I was born on December 24th, 1971. At that time, the planet was called blue marble. But 3 years ago, blue was not seen anymore, and the planet was gray and brown because of the environmental damage. Then something strange happened, and in early 2020, the blue face of our planet showed up again, not because we intentionally change our behavior, but because we have been locked down by a virus. We live on a planet around which we have been able to establish in just few decades a global landfill with more than 170 million pieces of space debris. Pieces smaller than 10 centimeters, you have to add another 650 of 10 to 30 centimeters, and 80,000 above 30 centimeters. This is what is above our heads, and what's below our feet. We dig inside, hunting for the only criteria of success, which is more. More money, more people, more companies, more cars, more houses, more businesses. More is the only criteria of success. Ask Fortune 500 members, Elon Musk, Jeff Bezos, Mike Bloomberg, Bill Gates, how they get to the ladder. We are living on a planet together with 7.95 billion people, not knowing that 200 years ago it was just 1 billion and 100 years ago just 1.5 billion, which means in the last 100 years, the human population 5-folds, despite of 2 world wars, 2 world pandemics, and more than 650 war conflicts, which happened since 1945. And in 2050, some predict there should be 11 billion people living on the planet. And just now, please remember the last image I'll show you. We are living here in 206 countries, according to UN 193. We are speaking 7,000 languages. We run 1 billion cars, and we let 9 million people die hungry every single year, despite the fact that every single day, globally, is being wasted more than 23 million metric tons of food and crop. We let 800,000 people die thirsty every single year, despite the fact that only California crude oil industry consume every single year every single day, more than 347 million liters of drinking water. We grow our food to throw it away because the leaves are for the buyer in a chain store not green enough. We put our overproduction in a rivers and on a landfills not to spoil the market price. We carry our water in firefighting tanks not knowing that the same amount of water is needed to produce just one and simple hamburger, and we do it on a planet on which this image is a reality as well, showing that one sip of water can save not one, but 2 lives. We work in factories with walls filled with environmental certificates, and behind the walls, landfill is being created. We park our obsolete packaging on a parking lots for employees, waiting till it becomes waste. Unperfect goods, because of the quality control, are being wasted instead of serving hundreds and thousands of others. We are listening to the words of World Bank, which says that till 2050 the waste volume should grow. In some destination it should even double. Despite the fact that almost everything can be reused or repurposed, but in fact only 13.5, according to this report, is being repurposed. And this is what made waste industry the 3rd most profitable industry in the world, just after the war industry and crude oil industry. What is the relation between mining and waste? Very close one, because mining is being considered one of the worst environmental industrial activities, leaving a deep carbon footprint and waste footprint behind. Extraction, disposal, transportation, storage, and even the consumption create waste. But is it really the biggest one? And how big is the waste? If you take coal out of the ground, you take same amount of waste. If you start with ore, good ore, you take twice so much waste than the material you need. If you speak about gold, 1,000 times more, and diamonds, 10,000 times more. And what other industries? And you may be surprised. 40% of energy is being lost during the transmission. 54% of wooden packaging is being used just a single way and thrown away and wasted without any damage. 60% of fish, so-called bycatch, is wasted in the ocean fishing industry. 75% of all crop and food is being wasted before reaching the 2nd stage of production. 95% of drinking water can be saved if new technology for firefighting will be applied. And 96.7% of offices are being wasted for more than half time in a day. What are on-the-ground mines? These are the existing resources. This is something what we already have, but instead of utilizing, we call it waste. It has a different forms, different shapes, different volumes, but the principle is all the time the same. Somebody does not need it, so it's being wasted. This is not parking lot in a front of a Black Friday shopping day. No, this is a graveyard of new cars, graveyards which exist in almost every country which produce cars. These are cars not being produced for being sold, but they are produced because to fulfill the investors' requirements. And this is just small part of wasting, which happens on this planet, around which we created a landfill, and we try to do the same inside the planet. The reason for that is that we have built our future on the top of a pyramid, considering that the pyramid is the best shape for the future, not realizing that these pyramids has not been built to keep living people inside, but dead corpse. I realized that more than a decade ago, and I created another groundstone on which the future can be built, much stable one, call them 6R. And how does it work? it's not easy to use it, because firstly you have to recognize that something must not become waste. And if you do so, the even harder step came, because you have to reconsider what to do with it. But then the reward will come. You will fail probably for the first, second, third time, but then when you succeed, in this moment you will start to change the world. How does mining industry will look like in the age of Industry 5.0? Firstly, the mining industry will not just dig inside the earth, but will utilize the on-the-ground mines. We will think once, but use twice everything what we have, turning from wasteful to wasteless. And we will create new complex environment by communication and cooperation between the industries. The sustainability will be applied before something happens, not after. And the logistic will become a crucial part of the system. Mining will not damage, but protect the environment. And mining is construction in the future, not the decomposition. The new mining industry must harmonize with all the segments, not just with the mining or just one consumer. Then the main tools are creativity, openness, research, and communications. They are missing. We will not waste our time by asking 5 times why, when we can think and ask for the first time the right question. Landfills, overburdened machinery, machines will serve even after their first life and dedication. Every trouble can turn into treasure, and Industry 5.0 do it systematically. Minor will be dedication again, not shame or punishment. I was asked in the 9 years of doing my job whether there is any value of systematic waste prevention, and in 2019 we have introduced this number. We spent a lot of time calculating it. $475 trillion of saving, which can be realized in a single year, every year growing. But unfortunately today is not valid anymore. The reason is the war in Ukraine. The value of systematic waste prevention increased for the first time in human history to $1 quadrillion US, because not a single shot will be reused and not a single human life can be recovered. Dear ladies and gentlemen, we are not living in an ice age. We are living in a waste age. And because of that, we need legislation, and I spent 8 years to write it down. And here it is. Nothing that can be used or utilized again must become waste. Everything must be considered primary as a pre-waste existing resource and remain in the system. The secondary use or utilization is not limited to a primary function of a product or material and can be utilized by everyone respecting the rules and regulations of the country. Collecting, sorting, baling, and trade are not being considered anymore secondary utilization, and if not utilized on a primary location, it must be offered to others before being wasted. And dear ladies and gentlemen, there is one important thing to remember. There is no waste if we do not waste. Trust me or not, but there does not exist a single legislation in the world which defines how a product becomes waste. So it must be part of the waste prevention legislation, because wasting is a process in which a product or material of any kind, form and volume become waste. In fact, wasting is a system failure and must be prevented first without any restriction or legal limitation, and please understand. And remember that for the rest of your life. Wasting is not a feature of a product or material, but the result of human behavior. And single use is one of the most frequent forms of wasting. What are the waste categories? It's a physical waste. This is the trash which we find out in a garbage. But there is another one, it's a social waste, people and animals which cannot live meaningful life. And there is a urban waste, which was discussed yesterday during the conference and will be discussed today as well. These are the brownfields, but even new green fields, which are established next to where existing brownfields are placed. And there is a process waste which is omnipresent in every single industry and business, including bank, education, politics. Did you know that 55% of shipping containers are shipped all around the globe with just air inside, despite the fact that in 2010 was already introduced a collapsible shipping container? Dear ladies and gentlemen, Industry 5.0 is the first industrial evolution ever led by man, by human. It is the new mindset of businesses and individuals, from wasteful to wasteless. It delivers results without the need of capital investment, and it's based on the principles of systematic waste prevention. It utilizes the on-the-ground mines, and it's based on transparency, profit sharing and efficiency, and please do understand one. Industry 5.0 is not a sales tool or a buzzword or a fifth industrial revolution. That's a misleading concept, which is being shared by some who try to make it as a sales tool for the machines, which has not been solved with Industry 4.0. Dear ladies and gentlemen, we are living in the age of digitalization of our work. Our children live for 2 years in a time of digitalization of the education, and our leisure time was digitalized long time ago. So it looks like there is only one thing needed to be digitalized, and this is the human himself. But if we do so, our home will look like this. And this is not a mistake, because data don't need any light. I have realized a decade ago, and I have decided I will not live on the bottom of a black hole, and I started to build another home, wasteless world. On January 1st, 2021, we started so-called 17 Challenge, Global Recovery Challenge, in which we say that we can recover the global society, economy, industry, and environment in the same time, which needs COVID to put everything down. Dear ladies and gentlemen, my name is Mike Rada. I'm human. And don't worry, I'm not alone. At the moment, there are Industry 5.0 ambassadors in 104 countries already, representing more than 7 billion people. I took my decision how the future will look like and what I will do to achieve it. Right now, it's your time to do the same. And at the end, let me thank you, because you gave me right now the most valuable assets which you have, your time. And I hope not a single second was wasted. Have a nice time, free of waste and wasting in all its forms. Stay safe and free, because only these three together will help you to live meaningful life. Have a nice day and stay safe.
Thanks very much, Michael. Thanks for that very thought-provoking and challenging presentation. No, appreciate it. Now, we do have a little bit of time, I think. Arthur's going to let us have a bit of time, even though it's 5:30. Has anybody got any questions for our 7 presenters? Tony Lund over there, please.
This one's for the ore sorting. You mentioned the operating cost. Can we have a quick idea what each type of your ore sorting machines would cost for a medium production operation?
Did you hear the question, Jason?
Yes, I did. Just to rehash that question, you're asking how much each machine would cost, the price of each machine?
Yes. Yes, each type of machine. The spherical one was of interest to me.
Sure. Our Circle series does range from about 1 million USD to about 1.5 million USD. This is, based on each model. It uses different detection technologies. As I mentioned, we can definitely tweak and adjust that for our customers. So there is a range in terms of pricing. Our other machines do fall under that. We do try and keep the cost low because to us, not only is the economic portion important, but the environmental part, trying to get people to create greener beneficiation processes.
May I ask you, Jason, one more question as well? Please, can you tell me whether you try to use your machine outside of the mining industry? I have spoken about reuse. For example, my idea is to reuse the material which is stored on a landfills. And with your technology, I can imagine it can be usable. Did you try?
Yes, we have considered moving into other industries, but as we mentioned before, currently we are extremely focused on ore sorting because there is a lot to improve there. So we definitely think that there is potential in the future to move into recycling a lot of the waste that you mentioned in Industry Mining 5.0. But again, the mining industry itself, in terms of mining minerals, still has a lot of work. So we want to continue improving on that and bringing our technology to as many mines across the world as possible.
Okay, thank you.
Any other quick questions? I just had one question for you, Glenn. I looked at your list of sponsors and contributors, and I was thinking, well, where are the big inputs from potentially the majors? And I know that people like Rio and BHP and Anglo are kind of looking at mines of the future and whether they, you're in touch with them or what they're doing, if we know what they're doing, because they put a lot of money into this type of thing. I don't know whether it's robotics or perhaps I'm asking the wrong question because you're stepping in for Victor, but yeah, it's interesting that I don't see the big mining majors in that list of sponsors.
Yeah, I don't honestly know the answer to that, and perhaps some of those of you who are more plugged into the industry would have a better perspective. I wonder if it's because of the technology readiness level. It's around about, I don't know if you're familiar with that kind of scheme, which runs from 1 to 9. This is operating around level 3 or 4.
Early days. Yeah.
And I'm thinking on my feet here compared to, for instance, the energy sector, where they have very big R&D spends. I wonder if the nature of exploration risk in mining being what it is, that they don't want to, operate on that sort of bleeding edge in the same way that they might in energy. I don't know.
Okay.
Very good question.
Thanks.
I'll ask Victor.
Yeah. Any other questions? If we don't have any other questions, I'd like to thank again the 7 presenters who've held us through to the end of the conference, well, the end of the technical conference anyway. So thank you very much. They're all excellent presentations, very thought-provoking, very interesting. Thanks again. Thank you.
Thank you.
Thank you.
I managed to convince Arthur that maybe I'd just say a couple of words just to thank him and the team, and thank all the presenters for all their contributions over the 2 days. One of the reasons we sponsor MINEX and we have such a great relationship with the MINEX team is that they bring together they bring together amazing speakers, excellent industry contacts, the governments, the UK DIT, and we get real results out of these. They're small conferences, but for us, they're a lot more meaningful than some of the other things that we are asked to attend or we're asked to contribute to. And I was just reflecting on everything that had been said over the last 2 days. We went through the full sort of, we went through the governmental regulations of West Balkans. We found out what's happening in Albania. We've been through critical raw materials, exploration, mining technology, processing technology, sustainability, the governmental framework. So we've covered a huge amount of topics right across the spectrum, and it's been absolutely brilliant. Really, I really appreciate it. I think everybody's loved Albania. I just thought maybe just as one takeaway for the conference, as I was thinking about it, and I kind of was thinking today what I could think of a good takeaway for the conference. I did have a slide, Anastasia, that I was going to show you. Do I press any buttons or? It's a picture of Jason. That was such a great presentation, Jason. I nearly went out and bought an all sorter immediately. No, it was brilliant. I don't have a mind to put it in,
just a moment, Richard. It's coming up.
Yeah, this is just a one takeaway slide that I thought kind of helped us get our heads around everything we've talked about these last 2 days. And this is something that EY do every year, and they do a top risk for miners. You've probably seen it, and whether you agree that what the process or how they do it or what the rankings are, it is a good reference point for the industry. And I particularly like the fact that they tell you what the rankings were last year. But look at those 3 key risks to the ESG, to investment in the mining industry. ESG, decarbonisation, license to operate, right? And you think those are the only 3, but then you go up and you look at all the others, and 7 of them are actually very, very intensive ESG. So, my takeaway was you can have the best deposit in the world, you can have the best team, but if you haven't got your ducks in a row for the future around, your environment, your social governance, your decarbonisation strategy looking forward, and and without those, you don't get a license to operate. You're on a non-starter. So we've covered the range, but at the end of the day, think of those things, and that's what sustainable mining is all about. So thanks, Arthur. Thank you for the opportunity to moderate and present, and just again, thanks to all the presenters. It's been a really good conference. Thanks a lot.